So hello, welcome. General idea today is you have an exam coming up. There was an exam this Friday, November 6th, that is going to be from 3 o'clock to 4:05. So in general, I want to make sure we get some review done. This week's going to be a lot like the week leading up to exam 1, which what I mean is today I'm going to go through last year's exam. Wednesday will be a open review session where I'll cover whatever people want to see, and whoever's in the room can ask questions. Those of you who are watching the videos, you can also email me questions and I can do them like this. And then Friday will be the exam. The exam setup is basically the same as last time. On Banco Hall, if you go down to the exam section, there will be exam 2 fall 2020. It'll be the same thing with full problems. Each problem will be its own piece. You take a picture, you upload. If I look at the last year's exam, this is last year's. This isn't your exam. You know, it'll start with an opening thing, kind of giving information, and then each problem will be posted. And yeah, you just post a solution. I am still doing them one at a time because I am randomizing numbers. I do ask you work alone. That's why I'm randomizing numbers. But that's the general setup. So as I said, I want to go through last semester's exam, starting with that one I just had open. And I guess I'll just jump into it. So this exam is going to be 4 questions long, and it's covering 4 chapters. Each problem is going to be from one of the chapters. So it's going to be a problem from 24, a problem from 24, a problem from 25, a problem from 26, a problem from 27. The problem from 24 will be your first one, where the 24th chapter was about induced EMF, and will either be about induced EMF or maybe inductors, dealing with just inductors in general or LR circuits. In a DC sense, AC is the chapter after. But what I did last semester was I did induced EMF. And induced EMF, there's a good chance it's going to be involved in that. And the problem is as follows. Magneto, the mutant master of magnetism from X-Men, starts using his power to supply an increasing magnetic field at Colossus, a mutant coated in metal. This field, which goes from 0 to 5 Tesla over the course of 2.45 seconds, is perpendicular to Colossus's arm. Well, actually, it's parallel to his arm, perpendicular to the area of his arm, which can be approximated as a single-turn cylinder of conducting metal with a radius of 7 centimeters, as shown in Figure B. And so what we're saying is his arm's coming straight out, the magnetic field is going straight into his arm. And so that bottom figure is you're looking at just a hunk of his arm out. And it says, if the resistance in Colossus's arm is whatever, how much current flows through it from the changing field. So what we have is Magneto changing the magnetic field. Anytime you have a changing magnetic field, you have let's go up here. You have an induced EMF, where the induced EMF is negative N change in flux over change in time. Well, N is the number of turns. So if it's a coil of wire, how many? Now, it says it can be approximated as a single turn cylinder of conducting. I wrote that right here. A single turn means N equals 1. So that means the induced EMF will be negative change in flux over change in time. But flux, we need to work out what flux is. Flux is, by definition, the magnetic field times the area times the cosine of the angle between the two. Now, in this case, the fist is pointing straight out of the page, and B is pointing straight in the page. They'll parallel. Really, the fist pointing in the page or the fist pointing out of the page will have the same effect. And that means the angle between them is 0 degrees. If the angle between them is 0 degrees, the cosine of 0 is 1, and I can just say that the magnetic flux is BA. And I'm going to plug that into this equation, that EMF equals negative change in BA over change in T. Now, I want to do something kind of silly here. I'm just going to drop my negative sign. The reason why is the negative sign represents directions. The negative sign in itself is Lenz's law. It shows that the induced EMF opposes the change in flux. We're going to use that for part B, which we're talking about what direction it's in. But for now, we don't need to include that because that's just going to be for direction. It has nothing to do with magnitude. We're looking for, right now, the magnitude of this current. So I say, okay, there's my equation. Now, the area of Colossus's ulm isn't changing. His ulm has some set cross-sectional area. That's not going to change. So I can take that out of my change in because it's constant. But the area of his ulm, it's a round thing. It's just going to be pi r squared because his ulm is approximated as a cylinder. And that just means that the induced EMF is going to be pi r squared B final minus B initial over time. I really could say T final minus T initial, but it's the amount of time that elapses. And using that, we'll get that the EMF is pi r squared, 0.07 meters, times B final, 5 Tesla, minus B initial, 0 Tesla, over the time period, 2.45 seconds. And when I do that math, I get 0.0314. Really, that? Yeah, okay, yep. Volts. And that's the induced EMF. So if I wanted the induced EMF, we're good. Thing is, I didn't ask for the induced EMF. I said, what is the current through his ulm? Now that uses an equation that is not on this thing over here because it's from an earlier chapter. There's a version of it kind of over there. Nope, it's not in there at all. Huh. But it is an equation I expect you to know, which is Ohm's law. And Ohm's law states V equals IO. But EMF and voltage really are the same basic thing. You can just easily say EMF equals IO. And that means the current is the EMF over the resistance. Or 0.0314 volts over 120? 150. Over 150 ohms. And we get a current of 2.09 times 10 to the negative 4 amps. And that is the magnitude of the current. That is how much current would pass through the ohm. Now there is a part B. Is this current clockwise or counterclockwise, as viewed in figure B? For whether clockwise or counterclockwise, you're going to need to think about that Lenz's law idea, that minus sign. See, what we're saying is that B is into the page and getting bigger. Induced EMF wants to undo changes. And so we're getting more EMF into the page. If we're getting more EMF into the page, it's going to induce the EMF out of the page, trying to undo the change. And so if B is getting bigger in, you'll induce out. Keep in mind, it's always to undo the change. It's not just that B is in that's in. If the B was pointing into the page and getting smaller, then it would be into the page. The induced EMF would also be into the page. Or the induced magnetic field would also be into the page, trying to undo the change. But because it's into the page and going down, since it's going down, we'll want to go up to counteract. And therefore, the induced EMF is going to be out of the page. Going to be out of the page to oppose the change. Now, my right-hand rule says if I point my thumb out of the page, I can curl my fingers in the direction of the, and this might be interesting because once again, things are zoom mirrors. So what you see, let's put it over here. If I want it to be out of the page, I'm going to induce an EMF following the right-hand rule. That I put my thumb in the direction of B and the current is going in the direction my hand curls. And my hand is curling in a counterclockwise direction. And so the direction is counterclockwise. Now I gotta be careful. When I do it on this screen versus this screen, it left-right reversal messes with me. Now the first one will be either induced EMF or something like an LC circuit. Sorry, LR circuit. Induced EMF is much more probable though. Mostly because I'm gonna deal with inductors on the next problem. This one had a changing magnetic field. I might do one with a changing area. Think of like the problem in the notes that had like a loop falling through a magnetic field. Maybe I can have the magnetic field moving somehow. So I could do instead like the field is changing or the area is changing, or I could have it spinning, but that's the general idea. Any questions there? Okay.
Ideally.
Sorry, what was that?
I said ideally you'd only be having one variable changing for our problem, right?
Yes. Having both the area and the magnetic field changing on the same problem would be a bit of a mess. I wouldn't do that.
Thank you.
It would be kind of hard to do one like that without involving calc. Actually, I don't know if I could do that one without involving calc, to be honest. The next problem will be from chapter 25. And chapter 5 was the dreaded AC circuits. And it's going to involve the AC stuff. Now, AC has a big ass box of information it could be. Everything up there in that red box I just made. I might do stuff with RMS to max. Impedance will almost definitely show up. I might do resonant frequency. I might throw in a transformer just for shits and giggles. But capacitive inductance and, sorry, capacitive inductance is another thing. Capacitive reactance and inductive reactance will probably show up. I might ask if the current leads or lags. The phase angle will probably show up. In general, it's going to be that block of equations. And this is okay. So last year when I gave this exam, every single person finished the exam early. This exam was a kind of a fast one, and we'll get into why that is when we get to question 3. This was the most time-consuming problem. And on this year's exam, I'm going to be honest, it's still kind of the most time-consuming problem. But it's not necessarily difficult, it's just a bit of algebra. And so what I asked last year was transistor radios use RLC circuits to tune to various radio frequencies. Let's say we have an RLC circuit with a 150 ohm resistor, in series with a 4 times 10 to the negative 7 Henry inductor, the tiny ass inductor, and a 3 times 10 to the negative 11 capacitor. For a frequency of 97.5 FM, which is 97.5 times 10 to the 6 hertz, what is the impedance? If I want to get impedance, the equation for impedance is Z is R squared plus XL minus XC squared. If I want to get impedance, the first thing I need to get is my capacitive reactance and my inductive reactance, my X of C and my X of L. Now, X of C is 1 over 2 pi FC, and X of L is 2 pi FL. And for each, I'll just plug in 1 over 2 pi times 97.5 times 10 to the 6 hertz times C, 3 times 10 to the negative 11 farads. I don't know why I put a C there, because I was thinking capacitors. This is farads. And I can do that math. 1 divided by that entire mess is 54.4119 ohms. X of L is 2 pi times 97.5 times 10 to the 6 hertz times 4 times 10 to the negative 11 henries. And that's going to be 245.044 ohms. And now that I have both of those, I can find my impedance, which was, yeah, I was looking for impedance. Where Z equals R squared plus X of L minus X of C squared square root of. And that means the value is going to be 150 ohms squared plus 245.044 minus 54.4119 squared square root. That pen is dying. Random color switch, which you can do the math and get 243 ohms. Part B, what's the phase angle? The phase angle is the inverse tangent of XL minus XC over all. And so it's 245.044 minus 54.4119. And I can get that angle. as I said, these will probably show up in some form. General ideas, it's just plug and chug. It's normally not too, like, the last one you had to think, okay, I need to use EMF, how? These are normally a little more straightforward. It's like, it's something about impedance. If I want to get impedance, I just use that equation. The only time I get fancy, maybe if I involve current, where you'll just use Ohm's law, but phi equals IZ in this case. Now, the one from last semester did have a part C, and it said it's hooked up to an AC power supply with VRMS of 110 volts. What's the max current? Well, if I know VRMS, I can say VRMS equals IRMS Z. And therefore, IRMS is VRMS over Z. And so it'll be 110 volts over 243 ohms. And that tells you that IRMS is 0.453 amps. Thing is, that's not the max current. It says what is the maximum current, but I got the RMS value. What I can say is I max is the square root of 2 times IRMS. I kind of went straight to rearranging this equation. You know what, let's just do this real fast. I kind of went straight to just rearranging this equation right here, that IRMS is I max over the square root of 2. So therefore, I max is IRMS times the square root of 2. And now this is a slightly different size. But you know what? That all fits better. So we're going to go with that. And I'll just say it's square root of 2 times 0.453 amps. And that math gives me 0.640 amps. Very tiny in the kernel, as I lose the focus. I don't know if IRMS versus IMAX or VRMS versus VMAX. I literally don't remember if it shows up. I had a real hard time thinking of a fun problem for this problem, though I did get one in the end. But definitely impedance will show up in some way. Phase angle probably will too. I kind of expect Ohm's law to show up in some way. I don't remember what I asked. I wrote the exam a week ago. I don't remember it anymore. Any questions?
Nope.
Okay. The third and fourth problem are both going to be optics. The third one from 26, the fourth one from 27. And these are going to be some of the easiest problems you get in this class. I know some people are struggling a little more with optics than others, and I don't mean to belittle any struggles people have, but the rearranging the calculations are a bit simpler. The first one from chapter 25, that would be this collection of stuff, the reflection and refraction equations. And really the only trick comes out of these comes from dealing with geometry normally. You have the law of reflection, where the incident angle equals the reflected angle, and Snell's law for refraction, n1 sine theta 1 equals n2 sine theta 2. And the only other equations that came up was the speed of light in a material versus the index of refraction, the speed of light in general, and critical angle. Well, critical angle just happens when one of these signs ends up needing to be 90 degrees or greater. The problem I did last semester says light ray hits a block of polystyrene surrounded by water at an angle theta as shown below. Find the maximum value for theta for which the refracted ray will undergo total internal reflection at the left face of the box. So what I'm saying here is theta c is at the critical angle. But I know the critical angle is equal to the inverse sine of n2 over n1. Now, in this case, that's when you're leaving a material. And that means n1, let me draw, is going to be for critical angle, it's assuming you're coming into something and leaving it. That means in this case, n1 is going to be the polystyrene of value 1.49. N2 is going to be the wattle. If I try to do the other way, I'm going to get an impossible to solve number. And because I know it's polystyrene divided by wattle, I don't know why I'm using calculator, it's just right in front of me. I can go and I can find what that angle is. That the critical angle for polystyrene to wattle is just given at 63.2 degrees. And that's theta C. Now I don't want theta C, I wanted theta. But here's the thing. If I go and say this dotted line, let's just continue it further out. And this dotted line, let's just continue that further out. I just made a triangle. I made a right triangle where that right there is 90 degrees. And the sum of angles in any triangle is 180. So I know that 180 is going to be 90 plus theta C plus some other angle at the top here. Now that angle at the top, which as of now is unmarked in any way, shape, or form, that's going to be from when the light refracts in. I'm just going to call this a refraction. Let's just call this a theta 2. And say this theta, let's just call that a theta 1. And I'll say that that triangle is 90 plus theta C plus theta 2, which means 90 equals theta C plus theta 2. And theta 2 is 90 minus theta C, or 90 minus 63.2, more commonly known as 26.8. Now that I know that angle, I can Snell's law out and say n1 sine theta 1 equals n2 sine theta 2. Now I'm doing something stupid here. I'm switching what I call n1 and n2. But that's because I'm changing the materials. 1 is what you start in, 2 is what you end up in. And here we're starting in the water going into the block. So up here, I'm going to call this one and that 2. I flipped them. Now, if I didn't flip them, it would have still worked. Because n1 sine theta 1 equals n2 sine theta 2 is the same as n2 sine theta 2 equals n1 sine theta 1. As long as I kept in the glass with the glass and in the water with the water, it would have been fine. But either way, if I want that angle theta 1, I'll just divide both sides by n1 and say the sine of theta 1 equals n2 sine theta 2 over n1. Also known as 1.49 sine of 26.8 degrees over 1.33, which tells me the sine of theta 1 is, you know what? I didn't solve for it. It's something. And theta 1 is the inverse sine of that something. And when you do that, you get 30.3 degrees. I did to show you, I just did, why won't you, oh, that's why. I did it in one step. I took the inverse sine at the same time. I didn't get the piece in between. The problem for this chapter probably won't be too complicated. If anything, it has some weird geometry tricks, but I try not to give any I haven't done repeatedly in class. In fact, by I try, I mean I won't. Worst case is I might have you trying to shove together various terms, but you're just really going with Snell's law, critical angle, and maybe if I'm fancy, the law of reflection, which is the easiest one. But that's the general idea. That's what I hope it to be. Any questions on that problem?
No, not currently.
Okay. The last problem is going to be about lenses or mirrors. And I could do either one. If I do a mirror, it's probably going to be a curved mirror. Flat mirrors are kind of boring. But it will be a problem about curved mirrors or lenses. And for both of them, I don't care if you're doing a curved mirror or a lens. The general idea is going to be these equations. That 1 over the image length, 1 over the object length plus 1 over the image length equals 1 over the focal length. And magnification, which is the height of the image over the height of the object, is negative q over p. For a lens, there is a complicated equation called the lens maker's equation to find the focal length of a lens, but I would not necessarily expect you to do it. For a mirror, the focal length is, and I should really fix that equation, the focal length for a mule is plus or minus all over 2. It's not just all over 2. For a converging mule, it's all over 2. For a diverging mule, it's negative all over 2. Know which mules are converging or which are diverging. That a converging mule is a concave mule. A diverging mule is a diverging mule is a convex mule. Same idea that a converging, like, just know that stuff. Also know when to make any of the terms positive or negative. Now, here I ask about a lens. And what it is for a lens, and I can just scroll up in here and I should be able to find the table. For a lens, this is what we're going to have. That a lens has a positive object when it's in front and a positive image when it's behind. And the focal length is positive if converging and negative if diverging. So this problem says, in honor of the release of Ant-Man and the Wasp, Marvel released a tiny comic that came with a magnifying glass so you could read it. This is a true story. The magnifying glass was a converging lens of focal length 25 centimeters. That means f of this lens is 25 centimeters. I don't need to make it negative because it's converging. If I said a diverging lens, you'd have to suddenly make f negative. I won't necessarily f is a positive value, f is a negative value. I expect when I say converging or diverging, you know which one to put. Also, I know we always like try to work in meters. With lenses, I sometimes cheat and just work in centimeters. The reason why is because everything is in the same term. I'm going to still work in meters here because I prefer to. So I'm going to say f is 0.25 meters. So magnifying glass has a focal length of 25 centimeters, and you held it 13 meters away from the comic. That means the distance between the comic and the lens, the actual thing and the lens, is 13 centimeters. That means P is 13 centimeters, or 0.13 meters. Given that, how far away from the lens is the image located? Well, if we want to find the image, 1 over P plus 1 over Q equals 1 over F. I'll subtract 1 over P from both sides, say 1 over Q equals 1 over F minus 1 over P, which means it's 1 over 0.25 meters minus 1 over 0.13 meters. That math gives me negative 3.6923, 1 over meters. But that's not Q, that's 1 over Q. So I'll say Q is 1 over negative 3.69, whatever, 1 over meters, whatever it was. And I'll get a value of negative 0.271 meters. And that's my image distance. That's how far away the image is. I then ask, is it real or virtual? If Q, the following is true for mirrors and lenses. For both mirrors and lenses, if Q is positive, it is real. If Q is negative, it is virtual. This Q is negative, it is virtual. What's the magnification? Magnification is negative Q over P. There's going to be negative times negative 0.271 meters over 0.13 meters. When you do that math, I get 2.08. So that's the magnification, 2.08. Is it inverted or upright? If magnification is positive, it's upright. If magnification is negative, it's inverted. This is positive, so it is up. I missed. It is upright. I might also ask you if it's magnified or reduced. If the magnitude of m is greater than 1, it's magnified. This is 2 times bigger. That 2 times bigger means bigger. If you get a fraction, you get like 0.3, 0.3, or 0.333. If you get like 0.333, that's a third. If it's a third the size, it's smaller. Logic. But that's the general idea. The last problem, last year when I taught this, was super quick for most everyone. As I said, if I want to change it up, how I would change it up is just make it a meal. But if I make it a mirror, you're still going to be using this equation. You're still going to be using this equation. It's just you're not going to be using this guy. And all of this changes a bit. For a mirror, let's see if I can find it fast. As I accidentally hit my middle mouse button and stopped music on my computer. Where did I do it? Most exciting class ever, me scrolling. There you go. If I do it with a mirror, it's going to be this guy instead. I don't think it would be a bad idea to have these charts in front of you during the exam, just to make sure you know what you're doing, keeping track. Is this positive or negative? Keep in mind positive focal length for converging lenses, or converging, also known as concave. Negative F for diverging lens, also known as convex. Any questions on the fourth problem?
No.
Nope.
Okay, that is last semester's exam in 30 minutes. As I said, I did not have a problem with anyone running out of time last semester, so I'm hoping I don't have a problem this time because I know that you guys found the last exam a little long. I did time myself taking it. I still did this one within my time limit of what I give an exam for, but I did last time too. But this one definitely was quicker. Helps you don't have the Kirchhoff loop in there. But that is what I expect you to be able to do with all the hints I can. Since we have a lot of extra time, you can really spend the last 20 minutes doing whatever the hell you guys want. Any questions about the exam in general before I get into other things? No one unmuted, so I said no. Okay.
Nah, sorry.
You're gonna upload the blank PDF, right, with just the pictures?
Oh, I forgot I was going to do that. Yes. So what I would do, and I have to make that still, I completely forgot, thanks for reminding me, is right underneath the exam would be a PDF with no words, just full pictures. I might not bother with all full because, the picture on this problem right here is pretty useless, right? It's just there for the sake of putting something. You know what? Fuck it. No, I'll put all full pictures. But there'll be a PDF with just the full pictures. So if you want to print them to have, the diagrams in front of you, you can. I can do that. It's not going to have the words because those numbers get randomized, and I don't want you to have two different sets of numbers and confuse yourself.
That's all right.
I can do that. I will make that today and set it. It will show up when the exam shows up. It'll be right beneath it.
Thank you very much.
No problem. So, is there anything else you guys are still having a hard time with that you would like me to go over? I guess is the question.
For me, no, I think I got it.
Yeah. How about
So
you,
that's
Tim?
way nicer than forces.
You just hate forces in general.
Yeah, I'm not a fan.
If you guys don't have anything else, I'm just going to end early because, meh. As I said, Wednesday's class will also be for studying and stuff. So if you have any questions, you can also hit me up then. And I guess I'll stop there then.
All right.
All right. Homework's
Have a good
due
day.
Wednesday, right?
See ya.